Hi everyone, and welcome to my YouTube channel Chemistry Unfolded. Today we will study about thermodynamics. So let's start. To introduce thermodynamics, thermodynamics is the study of the transfer of heat from system to the surrounding. We have three types of systems. First one is the open system, where you see exchange of heat and matter, where you can consider the example of an open cup having some matter like coffee, tea, and which is hot. When closed system, there is just an exchange of heat, and in the isolated system, you see no exchange of heat and matter. For this, the example which is mostly considered is the thermos flask. Intensive property. This is the property that depends on the nature of the substance, like you have temperature, pH, EMF, molar heat capacity, specific heat capacity. Next up, we have the extensive property, which depends on the amount of the substance. By amount, I mean the quantity. Like you have mass, volume, resistance, conductance, heat capacity, enthalpy, and entropy. Now, there's one point to be noted. In the intensive properties, also, I mentioned an example of heat capacity, but that's molar heat capacity and specific heat capacity. So whenever you have molar heat capacity or you have specific heat capacity, that's intensive property. But just the heat capacity is an extensive property. Now when you take ratio of two extensive properties, what you get is an intensive property. Example is a density you can consider, which is a ratio of mass by volume, where mass and volume both depend on the amount of the substance, which means they are extensive properties. Then you have pressure, concentration. These are all extensive properties. But when you take ratio of them, you get intensive property. So always remember these three examples. Whenever you take ratio of two extensive property, you get an intensive property. Coming to the first law of thermodynamics. First law of thermodynamics is the law of conservation of energy, by which we say that energy can neither be created nor be destroyed, but it is transformed from one form to another. So the statement is given this way. du is equal to dq plus w, and work is given as minus of pdv. So in place of w, we put pd minus negative pdv. So we get the statement of first law of thermodynamics as du is equal to dq negative pdv. Coming to the sign convention part, when work is done by the system, we see expansion, and it's an exothermic process. Let me show you. What we said, expansion. So this is, say, suppose my system whose volume is V1. Now this system is doing some work. So whenever you do some work, you achieve something, isn't it? You achieve something. So when you see achievement, it is something big. So you see an increase in the volume, which I denote by V2. Now we know that my volume V2 is greater than my initial volume V1. So I take my work expression, wherein W is equal to negative PdV. Now negative P is at the side. Delta V or dV is given by V2 minus V1. Why? Because my V2 is greater. So it is given by negative sign. When you solve, you obtain a negative work. That means it is an exothermic process. So always remember, whenever work is done by the system, you get a negative work done. It's an exothermic process and you see expansion. But when you have work done on the system, meaning now someone is giving you pressure to that work. You are not doing it on your work, but you are pressurized to do. Say suppose you are pressurized to study. Will your output be more? No. Your output will be less. So say suppose my initial volume was V1 and my final volume is V2. Now we see that V1 is greater than V2. Now when we try to find the work done, W is equal to minus of P dV. What we get is negative P. What is delta V? As usual, V2 minus V1 only we do. But here V1 is more. So this V2 minus V1 will be negative, and this P is also negative. So when you solve this, you get work which is positive. That means endothermic, and you see compression because someone is doing work on you, someone is forcing you to do the work. You are not doing it on your own. Next we have path function. Now say path function meaning something which will depend on the path you take. So these are the function which depends on the path followed by the system and does not depend on the state of the system. Like you have work, heat capacity. They all depend on the path followed. Whereas a state function is the one which depends on the initial and the final position and does not depend on the path of the taken. Like say suppose I have a place A and I have a place B. I need to move from A to B. So this fellow state function does not depend on the path followed. Maybe I can go from here to here. I can go zigzag here. Or I can take a big turn and come here. But it does not matter for the state function. State function just wants to reach from A to B. It is not bothered which path you take. So that is a state function. It depends only on the final and the initial and the final position. It doesn't depend on the path you take. It just wants the result. Like you have pressure, volume, entropy, enthalpy, Gibbs free energy. Thank you. If you like the video, please subscribe to my channel, like, share with your friends, and all the best. Prepare well.